Is the blackboard visible to you? I want to make sure. Okay, thank you, Ariana. Okay, so I'll click on back, back to MATLAB assignment number 3 here. Okay, and in the second problem, it deals with a teller at a bank, and there's a queue of a maximum of n customers, and it gives you some information to help you compute the probability of the number of customers changing. So one thing is, like, in the problem, just in a nutshell, like if you have, like, let's say there are 8 people waiting in line, okay? I mean, if there are 8 people waiting in line, I don't know. I mean, if you don't want to think of a bank, think of like Chick-fil-A or something, right? Although they do serve people pretty fast, but we still see queues of people waiting in line for things. But if there are 8 people waiting in line, well, after a unit of time, like say a minute or whatever unit of time it is, maybe a minute or 2 minutes, the queue can change. 3 things can happen. If there are 8, I'm just giving an example. If there are 8 people in line, if that's your state, that there are 8 people waiting in line in the queue for the with the teller there. After a minute of time, the number of people in the line could stay the same at 8. Okay, that would mean the teller didn't finish with that person. Okay, and nobody new entered the line. And I don't want to give you too many clues here, but the number of people after a minute of time could go from 8 to 7. Now, what's that mean? What would have to happen for that? Or the number of people could move to 9. Okay, now what would need to happen for that to happen? If going from 8 people to 9 people. Okay, so there's, they give you probabilities to help you figure things out in the problem. But the thing is, like, if there are 8 people in line, after a minute of time, you can't go from 8 to 6. You can't go from 8 to 10. You can only go up. You can either stay the same, go up 1, or go down 1. Okay, does that make sense? So given that, they're saying in the problem here. Let me see here. I want to have it. They're saying in the problem, suppose that n equals 10. Suppose that n equals 10. Okay, well, we have to decide how big the matrix is going to be. So if n equals 10, that means that the maximum number of people waiting in line is 10. Okay, so let me ask you, what's the minimum number of people that can wait in line? The maximum number of people that can wait in line is 10. What's the minimum number of people that can wait in line? Who thinks they can offer that? That's right. That's right. Good, Benjamin. 0. So how many states are in this matrix? How many states are in this matrix? Well, so if we go to the whiteboard here, okay, and maybe I'll use my pen again. I have a matrix here. So S sub 0 would be the state in which nobody's waiting in line. S1 would be the state that 1 person waits in line. S2 would be the state that 2 people are waiting in line. What's the maximum number of people waiting in line? Okay, for this MATLAB assignment 3, second exercise. That's right, Ann, and that's right, Eleanor. And what is n equal to in the problem? That's right, 10. Good, Justin. So how many states are there? How many states are there? That's right, Nafani. There are 11 states. So all right. So this is an 11 by 11 matrix. How many entries are there going to be that you have to fill in? It's an 11 rows, 11 columns. Good, Catherine. Good, Benjamin. 121 entries. Okay, so now what you have to do is figure out what the entries are. So I want to give you a little time to talk among your groups about this problem. Okay, so let me give you, like, maybe 10 minutes here. And but I'm just trying to give you guidance to get you started, to help get you started. Okay, I'll stop there, and I'll see you in 8 minutes. Okay.